Hi, my name's Clare. I'm 12 years old and in the intermediate category for Robogals 2019. My topic for the major challenge was the electromagnetic spectrum. I chose this idea when I wondered how microwaves heated up food so quickly without using heat, but radiation, much like how the sun warms us. The electromagnetic spectrum is a range of frequencies and radiation, including X-rays, UV rays, radio waves, and visible light. Visible light is the only part of the spectrum that we can see, and all the other colours range from different frequencies on the spectrum. This doesn't mean that the other frequencies don't emit light, but more that they're not sensitive to our eyes. UV rays, for example, aren't visible to us, but are to bumblebees. The easiest way to show how it works is in radio waves. Radio waves have the longest wavelength on the electromagnetic spectrum and are used very often in everyday life to transmit and receive data. For example, TVs, navigation systems, radars, communication systems, and radios. Radio waves can be divided into separate categories: AM, FM, and microwaves. It's similar to visible light. All the different colours have different frequencies, but they're still all visible light waves. AM, FM, and microwaves all have different frequencies, but are still radio waves. Microwaves have a frequency that are higher in frequency than radio waves. They're used for radar communications and heating food in a microwave oven. To demonstrate how they work, we can just use a microwave oven. AM and FM are more commonly used. They carry lots of data and can be demonstrated in many ways. AM stands for amplitude modulation, and FM stands for frequency modulation. The amplitude is the height of the wave, and the frequency is how often the wave occurs. FM radios work by changing the frequency from the transmitter while the amplitude stays the same. AM waves work the opposite to FM waves. The amplitude is changed, but the frequency stays the same. If we turn on the radio now, you'll hear something come up. These are FM radio waves that travel from the specific studio or station that we're listening to and reach the radio's antenna. If we change the frequency on the radio, you're going to be moving around tiny little parts up and down on the electromagnetic spectrum. FM radio waves are often used more and sound better because they have more bandwidth, but are impacted by physical barriers. AM radios don't sound as good because they have less bandwidth, but can be transmitted for longer distance because it has a longer wavelength. If we change it to AM now, you'll be able to hear a difference.
Expert Kate Devlin of King's College in London.
If you listen to AM, you'll hear that there's more static and white noise. As it's less commonly used, it's harder to find a station, whereas in FM, you can turn it on at any time and you'll most likely come across a station. During my research project, I learned a lot about how waves on the spectrum work and how it interacts with many forms of science, such as physics, engineering, and simple devices we use every day. I also learned about how different variables can affect the result. For example, how AM radios sound different to FM. I participated in the Robogals competition because I get to learn about something I wouldn't get to otherwise, and because I really love science. Other girls should definitely participate in this challenge because it's an incredible experience, and you can learn about any field of STEM that you want to. It's great because you can do the workshops with other girls who enjoy STEM subjects as well, or by doing minor challenges at home. Overall, I enjoyed doing the minor challenge, science and engineering day, and the major challenge.